I sort of want to build on what Bob was saying and give you a specific example of a collaborative project between the University of Maryland and College Park and USDA or Escort Park. The project is entitled The National Scale Assessment of the Impact of Climate Change on Asthma Morbidity. It's being funded through the National Institute of Health for approximately $200K. The PI for the project is Amir Ziska. He's with the Maryland Institute for Applied Environmental Health. He is a public health specialist. I am a collaborator. I'm a plant physiologist with the Crop Systems and Global Change Laboratory. The research leader is Dr. Reddy. And you might ask, and I think it is a reasonable question to ask, what, given these sort of very disparate points of view and points of discipline, how do we come together to work on a collaborative project like this? Well, to sort of begin with, I focus on a lot of my work on the weed issue that Charlie mentioned and how will weeds respond to climate change. And one of the more important agronomic weeds is actually ragweed. And as Charlie also mentioned, it's very difficult to do the kind of experiments that we do. It's expensive to do the experiments in growth chambers. So to think outside the box, what we try to do is to set up an urban-rural transect where the city of Baltimore is warmer, has more carbon dioxide, and essentially represents the climate for the globe as a whole 20 or 30 years into the future. And we transect with the same ragweed seed, same soil, and so forth. And we set it up in a farm, rural site on the edge of the city, and then downtown Inner Harbor site. And what we did is we actually, as part of the overall experiment, measured ragweed pollen. And this is the change in grains per cubic meter of ragweed pollen beginning of day of year about 229, ending around 260. And as you see, the overall amount of pollen increases dramatically, about tenfold when you go into the downtown area. The two arrows that you see here essentially correspond to the beginning and maximum pollen release from the rural site. So we had this information that had been published, but it was sort of still regional, and of course we're really interested in looking at it from a large scale point of view. We want to look at it from a continental level if possible. So here again, we're looking not so much at the CO2 aspect, but more at the warming aspect. We know from the IPCC projections, this was mentioned earlier by Dr. Bosch, that there's more going to be a polar change in temperatures. These temperatures should be warmer, rise quicker than these temperatures, say, in the southern part of the U.S. And we wanted to see if, in fact, this was true for the overall length of the ragweed pollen season. So I contacted the National Allergy Bureau. I convinced a number of medical doctors that I wasn't some crazy scientist who was out to steal their data, and they were very generous in responding. And now if you go to the EPA website, you'll see the data in terms of changes in length of the pollen season for ragweed along this north-south transect from southern Canada down to Texas. Now this caught the attention of Dr. Ziska, and he was looking at that time on temporal trend and the growing season length. And without going through all the details, essentially what he was doing was looking at the sort of long-term average in 90th percentile temperatures. So how many days does it get above 90 degrees? And how many days in the spring, how many days in the summer in terms of freezing temperatures? And looking at the overall change in the temporal trend for the growing season length. And because he's a person who's interested in public health, wanted to look at this change in plant phenology related to climate and asked the question, why is this of interest in public health research? And he came up with the idea of asthma, earlier onset of spring, earlier exposure to pollen, higher temperature CO2, and so forth. Well, hopefully I've given you a sense of how these two different disciplines or two different areas of interest overlap. Because now we can come back to the ragweed data and say, okay, well, we have this transect already in line in terms of overall pollen. How do we then do that and combine both the projection for phenology with this particular data set as a means to basically ground truth what some of the projections are going to be with respect to growing season length. So again, this is a way of, as Bob said, thinking outside the box, looking at your own area of interest and thinking, well, who else might be interested in this data? How else can this data be used? So hopefully this will give you an example, and that's all I really had to say. Yes. I did a literature search looking at what essentially are the three plant-based sources of allergenic pollen. In the spring, it's principally trees. In the summer, it's weeds and grasses. And in the fall, it's ragweed. And so what we're trying to do is look at projected changes in the phenology, working with, plans are to work with Jake Wilson, who is, as mentioned earlier, is actually heading up the USA National Phenology Network through USGS, to take some of that data and basically get a sense of how that is going to be projected forward, not only with respect to the agronomic implications of greater weed pressures, but also with respect to maybe changes in public health pressures related to greater amounts of allergenic pollen and changes in the seasonality of that pollen.
Excellent that this multidisciplinary aspect that you're mentioning with doing case results and agriculture production, CO2 systems, and so together. And I know how many of those are pretty well as well. My question is this, that when you're doing gravity as an example on the different types of ecosystems, urban versus southern versus farm, I know that the temperatures have impact on phenology, but how does the impact of soil and nutrients available to gravity flows eliminated from the equation?
Well, typically when you look at farm systems, they tend to be fully fertilized, and water usually is, not always, but isn't considered a limitation. When you go into urban areas as well, you tend to have over-fertilization of lawns and so forth, and with drainage that tends to go into areas where ragweed is growing. So we don't see that as being a particular limitation to this overall projection. Most of the limitations, in fairness, ragweed is sort of an ideal crop to work, or ideal weed to work with us in regard. It's a short day plant. It only flowers after June 21st. It will keep on flowering until the first frost. So you can sort of use that as a very good model system working with public health officials to get a sense of how the pollen season overall is changing. I should also mention that the bulk of the money is going to Amir. We may get a grad student next year or this year to help with some of this. So it's a fairly small part of the overall project, but it does serve as an example of how you can take one area of your focus and sort of overlap it with others that are doing similar work, and that kind of synergy is really what we're looking for when we have these kinds of symposia.
Why don't we take a 10-minute break, get into that location, take a look at the posters, and I'll figure out what pen we can put up before lunch comes. Okay, thanks.